Okay. Hello everyone, my name is Shubham Raj. Today I'm excited to present on our heart classification on machine learning. I'm thrilled to introduce for my amazing teammates that are Neeraj, Bhavesh and Jay. We have chosen heart disease. Why heart disease? It is leading cause of death worldwide, and our goal is to use this machine learning to predict the heart disease in our patient based on the set of health features, so that we can detect and help them whether they are suffering from any heart disease or any other various diseases or not. So the question comes is, why did we choose this project actually? We simply chose this project is because of the alarming satisfaction statistics that are related to this heart disease. Basically, for instance, let's choose the US alone. So nearly 46% of adults are suffering from hypertension, having deaths around every 38 seconds due to the heartbeats and heart attacks. Around 2300 people are dying due to the heart disease on a daily basis, and these all data are from 2016 to 2015 records. Let me talk about why we are choosing and what are the data sets that we are generally using. Okay, so in our data sets, in our model, what we basically have done is we have around 11 features, starting from age, sex, chest pain, resting blood pressure, cholesterol, fast blood pressure, resting. So let me give you a brief intro and what are the range and everything, what basically we are doing. So age, we have restricted our model from age 1 to age 120 years, whereas sex, we represent it as 1 and 0, for 1 for male and 0 for female. Similarly, the chest pain is also where 0 means pain, 3 is the most severe pain, 2 is normal. Blood pressure is range between from 50 to 200 mmHg, that is its excuse me, sorry. Yep, sorry. Uh, so about the fasting blood pressure, where basically 1 means it is high, 0 means it is normal. ECG results is also ranging from 0 to 2, where 0 is being normal and 2 is severe. Whereas we also fill in the data that is max heart rate. Max heart rate starting from 60 to 220, whatever that cause which we would be placing that. Similarly, we also have similarly target, whereas ST scope and other stuffs. Also, we are also placing those values. So let us start. So this is the welcome screen that you are seeing in our page. So this project was given to us by Sandeep sir, who is our machine learning teacher instructor. And under his guidance, we have built this project. This project is entirely built on UI, whereas the backend is built on Python itself. We are using various sklearns and other models. So basically, we have targeted 5 models. So let me go and hit start so that we can proceed. So this is the model page where we are. So let me give you a brief intro about all the models that we are generally doing. So Neeraj is taking up on the MLP, whereas myself, I am taking on the random forest. So let me give you what exactly does random forest does. So let me select this model. Random forest, which means it is built on multiple decision trees and combines the result to make more accurate predictions. Also, it reduces the overfitting diagram, which is common in decision tree. It ensures better performance across all the different data sets. It is also good for handling larger data sets. It is efficient and perform well for both classification and regression tasks. Similarly, we also have how it works, let's say, is like it creates many decision trees using random subsets of the data, whereas each tree makes a prediction and final prediction is made based on the majority vote of all the trees. This approach makes random forest very accurate and less prone to errors compared to other single decision trees. So let me evaluate this model by placing all the data. So once I've selected random forest, I would be going to next. These are the feature sets that I had already discussed. So I would be giving all the pre-filled value, let's say 28. Sex that we need to pre-fill is 1. I am male. I don't have any pain, so I would be placing at 0. The blood pressure for me is close to around 98. Cholesterol, I don't have any cholesterol, so still it is a minimum, so I would be giving 122. The blood pressure for me is less than 0, so I don't have any fasting blood pressure, so it is 1. The ECG result is also close to 0. My maximum heart rate that I have monitored is close to around 120. No, I don't say 120. It was close to 105. That was max for me. Similarly, I don't have any angina, so it is 0. I don't have any depression or any other things. I also don't have any peak segment. I neither have any disease. So it is zero. So I would be selecting confirm data. So basically, this is the data that we have pre-filled. That is age 26, gender as 1, chest pain 0, blood pressure 98, cholesterol 122, fast blood sugar 1, ECG 0, max health 105, and 1 as exclude. I don't have any heart disease, so it is 0. So now, since I've selected this random for it, so what it would be doing is, let me run through the code actually. So coming back to the backend itself, so this is the backend where it would be getting handled. So we are making a API call where the API call will come here. This is the set of features, the data that we are passing in, and this is the expected size. What are the data that we are passing? So it is 11 basically. So here it will come to this data. We would be passing it. We would be converting this to the pandas data frame data, and we are simply calling this df and calling this train model. This train model is nothing but model.py, where we are using ML classifiers and other random forest gradient boost classifiers, and that we have taken from sklearn and XGBoost, where we are simply given this model. Like if someone chooses MLP, so we would be selecting this MLP diagram, random forest, then random forest. For me, we have selected random forest, so it would go to this random forest, where in model name I'm passing the model name that is coming from back front end, and this the input data is all the input fields that we have given. So once the data is trained, it does all the calculation in the Python itself, and post that we would be simply returning back the matrices that we show it in the UI. Coming back to again to the SQI, so let me show how we are simply triggering it. So as I showed you, so let me open the network tab. So let's say I have done the prediction. So in prediction, as you can see, I have shared the data. The data is being sent, like I mentioned, the features, all the features that we are sending, and the model name is random forest. And from backend, we are getting this accuracy. So this is what we are simply displaying in the UI. So prediction score 1, it simply means that I'm suffering from heart attack, close to heart attack. So I need to go to the doctor and I have to really show it. But still, on the other way around, so this is the prediction score. So let me summarize what exactly everything means. So let's go with accuracy. Accuracy simply overall indicates the correctness of the model. Similarly, F1 score is the balance between precision and recall. For log rows, it is the error that is probably based on prediction, whereas Matthew coefficient is overall model performance. Similarly, AUC and sensitivity is known as the model identifier, that what are the true positive and other things. Specificity, it reduces the model ability to reject false positive. So this is brief intro about each and every model results that we are giving. Parallelly, we can also represent the same graph in the chart itself. So this is the visual representation of the graph and that we have designed, and our team wanted this so that each and every person, whoever comes in the UI, can take these results and go and show it to any other operation. So this is basically our projects. Uh, so that's an overview for our projects. As a conclusion, I have successfully demonstrated how the machine learning can be predicted and predicts the heart diseases for and potentially saving the lives through the early detections that would be possible by using this model, likely random forest that I have used and shown the patient data such as age, cholesterol, blood pressure and etc. Can effectively, we can prove that whether it is having a disease, heart disease or not, or whether there might be a cause. So I would like to also extend a special thanks to Professor Shandip sir, from whose guidance and mentorship we have got this project, and we were grateful for his support and encouragement. Looking ahead for the possibility for this model, we want to enhance with the advanced data set, look deeper features and algorithms under his guidance. And also we would be working on a continuous monitoring on this project so that we can also implement some earlier later projects that we are. Finally, I would like to thank once again to my teammates, Bhag sir, Neeraj, Bhavesh, Arora, Jay, Singh, Khurshwa, for their dedicated and hard work. So I would be happy to answer any question if there is, and that's all. Thank you.